Cool. I'm gonna come back to making a couple videos for you guys. I'm sorry if the audio is not as good. I usually have a microphone a lot closer to my base, but this time around I'm using the one on my computer. All right, let's just take a look at what they have here. No need to go through it word by word, but if that helps, fantastic. We're basically looking at dilations. And dilations are essentially just scaling something. Okay, are you going to make it smaller? Are you going to make it bigger? Think about your eye and your pupil. It gets bigger and smaller as it dilates. All right. So this word dilation is essentially another word to think of when you're thinking about some kind of scale. However, when we're working with figures, with polygons, with any kind of geometric shape here, there are two things that we need to know if we're going to do a dilation. The first is what's the scale factor? How much bigger or smaller do you want me to make it? The other thing is the center point. So take a look right here. The center point here happens to be at this point. And I'm going to look at some examples in a second. But we want to expand this triangle and make it bigger. It has a scale factor of possibly 2. K is what they say when they want to generalize things. But let's take a look at an example here, and I think this will make more sense. Cool. All right, so if I've got a normal old rectangle here, all right, and that's a scale factor of 1. What if I wanted to make it a scale factor of 1/2? Let's go all the way down to 0.5a. One side went from 8 to 4, the other from 5 to 2.5. How about that? That's interesting, right? That's half, right? So a scale factor of half just means the sides are being divided by half. Well, if you haven't figured that one out, great. Here, welcome to the party. If I want to scale it by 2, look at the sides of my rectangle. It went from 5 to 10 and from 8 to 16. So that's pretty cool. All right, and we can sort of see that any scale factor is essentially just multiplying the side lengths by the scale factor. 2 times 5 is 10. 2 times 8 is 16. Okay, beautiful. So also notice that the rectangles, that doesn't lose any of its parallelism, right? It's all still parallel lines and they don't change at all, just the scale factor of the shape itself changes. So that's important later on, all right? Cool. I like this one because it really animates it well, I believe. So you can see there's equidistance from the point where the center of dilation is, all right? It's equidistant from there to there and from there to there. Also from here to here, and then again from there to there. So I'm just setting up my new points. If the point of the center of dilation is here, and it has a distance of 1, 2, 3 from here, well, should have another 1, 2, 3 to be at the C prime or C whatever, our new point. Now notice that as soon as you've made all of these points go out the same scale factor, the same amount, we've essentially just doubled where they are, all right? This point is now, instead of it say 3, 0, it's at 6, 0, all right? And instead of at 1, 4, it's at 2, 8. Both of the numbers there doubled. All right, cool. So whenever we're working on a dilation, just even with points alone, we can just multiply those points by the scale factor and we're going to get the new points. All right, take a look at this. You see the same idea. All right, this is using the origin, all right, 0, 0. As our point of our center of dilation. So you can see from triangle ABC, as it gets closer, scale factor gets smaller and smaller. I'm getting closer to 0.00, the origin. And as my scale factor gets closer to 1, I'm back at my normal triangle, my regular one. And as it gets greater, well, you're noticing it's getting bigger and it's getting further away from the origin as well, from 0, 0. Cool. There it is. That guy's all right. He did something cool in there. Isn't there one more thing on here that was pretty good? There it is. All right, cool. So this is a good one just to sort of see when you change where the origin is, how you wind up changing how the scale factors, how that wind up getting affected, right? So not necessarily the scale factor, but like how the direction that you move your scaled figure is changed. There we go, precise language. All right, so if I go back to a scale factor of 1, look at that, I'm just overlapping. I have two congruent triangles at a scale factor of 1. However, as soon as I start to dilate, there is no longer congruence. As you can see, this is not the same triangle. It is a dilated triangle. All right, so you notice as I'm getting closer to 0, it's going closer to the center of dilation, all right? And if I move the center of dilation around, all right, it's still staying close to the center of dilation. Now, if I have mine over here, all right, and I go above 1, it's going to be moving away from my center of dilation, all right? And so as the shape gets bigger and the scale factor increases, it should go further away from the center of dilation. There's a straight line right here, a straight line, all right? Just like we saw in the figure above, where we're duplicating something, all right? Let's see if I can make this. It's going to go off the page. Well, it won't even let me open it up even more. But anyway, all right, we'll do like this. Bam. That is my father-in-law. Cool. Anyway, so there's the idea as far as like where the scale factor is involved. All right. Hopefully that didn't distract. Awesome. The one thing I was going to also point out was this guy right here. All right. So they're saying, hey, take this line and I want to scale factor it by 3. All right. So I have my point, my center of dilation. That's P. And now I've got enough information in order to draw a line, right? I can draw a line so long as I have 2 points, or a ray in this situation. It starts at P, but then it keeps going forever towards A prime and B prime, okay? And then here's that same sort of animation, but I feel like it's even a little clearer. And you can see how it's multiplying each side length by 3. And what we wind up with is just points that are multiplied by 3. All right, so that's the cool part about it. So hopefully that all helps. And yeah.